class, and I came to know one thing, one very important thing. I realized that yes, one of the student asked me that yes, can there be only two components of the vectors? तुम like answer. Obvious that. Go. Can there be only two vectors of the component of a vector? So yes, is there anyone who is going to uh, answer my question? Maximum possible components. Yes. Can anybody tell me? Yes.
Sir, question repeat.
There can be,
Yeah. My question is that can there be only two components of any vector when we resolve it?
there could be more, I guess.
Or for example, how? Yes.
सर नहीं सिर्फ दो ही होते हैं.
दो ही होते हैं. Okay. Good.
X और Y
Uh,
एक्सिस पे सर.
X and Y. Okay. So basically, in the two axis, yani in Cartesian plan system, where you have only x axis and y axis, in two-dimensional system, you have two components. You got the point? You have two components only. Yani one component will be, for example, this is your f, so this is your fy, this is your fx. But in three-dimensional components or three-dimensional system, there would be more components, like three components. Remember this thing. For example, if I say that there is a fan, right? Right here, what will be its position with respect to ground? It will have certain position. With respect to this wall, it has certain position. With respect to this floor, you can say this will have certain position. It will have x component, y component, sorry, x component, y component, and z component. That is why once you resolve a vector into uh, yani into three dimensional system, then it has f x plus f y plus f z. But fortunately, we only have two dimensional system. Is that right? So,
So
okay, is it clear to everyone?
we just have to study the two-dimensional system,
Yeah,
right?
yeah, only two dimension. Actually, I told you that there was a question in my class. That is why I shared with you also. That is
So
simple. Okay, but there are some questions in the class which are helpful for all of the students, definitely. So that is why I used to keep those questions in my pockets to share with my kids in the streets. You know, this is very interesting habit of the senior citizens. They used to keep some toffees or some sort of candies in the pockets, and they used to distribute those amongst the kids who are in the street. So what happens in that case, that those kids are really happy. In this way, I used to put some questions with me. Okay, these are the questions for my online classes, right? And then I address those questions with you here. Okay, now moving on the next discussion. Actually, today's discussion is very important, and I will love to have your attention that we will be talking about the combination of the vectors, right? Combination of vectors, right? The combination of the vectors means it is commonly said addition of vectors, right? Lulu, is it clear to you? Addition of vectors. But all the times, vectors are not added. So that is why I used to call it to finding or determining the resultant of a vector, right? Resultant of vectors. So let's talk about this topic. In this case, I will have a short uh, debate with you that once you are having the forces under consideration, all the forces which are in the same direction, what do you think? Are they are they have the common impact? Or do they have the same impact when the forces are in the same direction? Do they have the same impact? Yani impact means, let's say, if I have a if I have a box like here, and that box is basically under the forces. This is one of the force, let's say 100 Newton force, and there is another force which is not 100 Newton force, but that is 20 Newton force that is in this direction. So, what will be the impact of these two forces? Isn't it the additional impact or impact like sum? Is it not?
Yeah.
So,
Yes, sir.
in this case, what do we do, or what do we say? That the forces in the same direction, they are simply added. Forces in the same direction are added. So, I can simply say that the resultant will be 100 plus 20, that is equal to 120 Newton. But if there is another guy who is going to apply a force of minus yani 20 Newton in this direction, what will you say? You will now say that 100 plus 20 negative 20 is basically equals to 100 Newton force. Is it clear to everyone?
Wait, so where did the negative 20 come from?
Negative is basically, yes, this is the question what I have to address. When vector is a directional quantity, it means that when the vectors are in the same direction, they will have the same signs. All the vectors in the same directions, they have same signs. Is this point clear to everyone?
Yes.
Right? So if I have two vectors in the same direction, they will have same sign. And those vectors which are opposite to each other, they will have opposite signs. Is this phenomena very clear? For example, whatever that is, that was 100 Newton, and this is, let's say, 80 Newton. So almost they are in the same direction, almost, because these arrows, okay, let's draw it in the same direction. Yeah, now it is. So what will be the net impact of these two? The net impact of these two will be how much? 180, right? 180, because this was positive, this was positive. But once you have the vectors in opposite direction, Lulu, what do you think? If you have a vector in this direction and there is another vector in this direction, so can I say that they are the negatives of each other? So, for example, this student is applying 100 Newton force, that is 100 positive. But if there is another student who is applying the same force but opposite in direction, it is 190. So, resultant force goes to, yep, what is the resultant force? That equals to zero. Yani
Zero.
the resultant of these two vectors is equal to zero. In this way, if you have different vectors, like suppose I have a vector x in this direction, suppose, and then I have a vector y in this direction. These are two vectors, and let me change their color to make you clear. These are two vectors, and these two vectors are just applied at this position. This is x, this is y. Okay, and I'm interested to get the resultant of these two vectors. If I combine, or if I want to combine these two vectors, actually I will have the vector, yani parallelogram of these vectors. Yeah, is it? So this is the vector which was basically over here. What was that vector? This vector was this one, isn't it? Is it not? I have just replaced it on the head of first vector. So that is why Now this vector is basically connected on the head of this. So this method is called head to tail method, right? Head to tail. Is this clear to everyone?
Yes, sir.
Yes,
Tip to
sir.
tail method. So by using tip to tail method, I can find the resultant. So basically, your resultant vector will be from tail of first to the head of last. So this is actually the resultant vector. And if I want to write that this is r, so I can write an equation for this, that the resultant vector is equals to x plus y. It is not the geometric x and y, a geometrical sum of x and y, but combination wise, it is what? It is basically the sum of x and y. Can I say that? Now
So
I have,
by adding x and y, you get the resultant?
yes, by adding, yani addition does not mean that add like scalars. This is what I wanted to explain. That is why I have given the name here to determining the resultant vector. Right? What you people are doing to have, you are going to find out the resultant of these all. Right? So resultant is commonly named as addition of vectors, or it is commonly named as combination of vectors. Is this clear to everyone?
Yes, sir. But could you give an example about the last thing that you explained?
Yes.
The x plus y is equals to resultant vector 1.
Okay, yes, yes, yes. I'm going to give you that example. For example, if you are saying that there are some vectors and those vectors are basically in several directions. For example, this was x and y. But now, if in the same condition you people are asked if there are two vectors, one vector is in this direction, x, right? And there is another vector which is basically your vector y, and that vector is here. Okay, that vector is here. Now this will be same as x and y. I will just name then that this is your vector x, this is your vector y. So now I want to add not x and y, but I want to add x and y in this way. So Misha, what will I do? Misha, are you there?
Yes, sir.
Yes, what will I do then?
There's a
Actually,
question.
it is addition. I want to explain it to you all. Yes, Lulu, Misha, Sayyid Abdullah, and Mariam, and Ali Faisal. Basically, it is nothing but it is sum of x and negative of y. Okay, Ali, बात clear हो रही है बच्चे? Is it clear to all?
So we're
Yes,
adding, but we're subtracting indirectly.
yes. Actually, what we are going to have, I'm gonna place this vector at the head of this. Then I will take a negative of this. Negative of this means this vector here. You got this? Yani this vector is basically y, but this vector is basically negative of y. Lulu, is it clear to you? Is it clear to Mariam, Ariba, and all the students? Not Ariba,
Yes,
sorry.
sir.
Uh,
Y-
rest of the students, rest all of the students. Sorry, sorry. It is
Yes,
difficult for me to just pop up the names at once. But is it
sir.
clear?
Sir, but how do we know that which value is going to be negative in each case?
This one, y, because y is taking a negative sign.
It's always going to be y.
Mhm. Only is this example.
Okay, so how do we decide generally that which one is supposed to be negative?
Um, the condition will be helping us to find it out. For example, here the y is negative is with y. In some other conditions, this negative can be with some other vectors, right? I can give you some other examples. Let me just complete this and then I will be back. Okay, here is what? Here is that z, vector z, which is basically the resultant of x and negative of y. Is it clear now? That basically I have yani rest all I will just figure it out, or rest all I will just uh, throw away. I will just give this situation, or I will just give this direction to my x and y. So for example, now I'm going to draw them in this way. X was here and negative y was actually here. Is it? Negative y was in this direction. And that is why your resultant was z was in this direction. So if I say that actually this is your x, this is your negative of y, and this is the z, and this z is giving you an equation of x and minus y. Now, if the same equation is asked to you, okay, draw a combination of, let's say, w, which is y minus x. So what will I do? I will keep this y in the original direction, right? Y will be in the original direction. What was the direction of the y? This was the direction of the y. Is it?
Yes.
This was the direction of the y, that black one. And I will place negative of x on the head of this y. So what is the negative of x? This one is the negative of x. You got the point?
So you change the orientation according to the
Yes, yes,
condition given.
exactly. According to my requirement, I will change the orientation. So it means now that this is W. So W is basically, what is this W? This is the negative addition of Y and negative of X. Okay? Yani, that is why I told you that the resultant will be starting from tail of first to the head of last. Is it clear to everyone?
Got it.
Yes, sir.
Okay. So here we go. I had yani these all are the situations which are basically uh, asked to you in different formats. So is this clear? Any question or any confusion till this point? Right.
No.
So in this way, the head to tail for head to tail for more than two vectors.
Sir, both of them can't be negative in any case, right?
We can make them, no issue at all. Let's do it. Y was in this direction. So negative of the y will be here and negative of the x will be here, right? Now, you cannot take resultant of this one. Why? Because they are not connected by head to head. So what will I do? I will just draw negative of x here. Is this clear to you? So in this case, the this vector is basically showing what? This vector is showing negative y and negative x. Are you getting? Yani you have taken negative y and you have taken negative x, but you have drawn the vector from start of first to the end of last.
Gee, I get
Okay.
it.
Okay. So is it clear to everyone? So in the case of vectors more than two vectors, head to tail of more than two vectors, there are some questions which are asked to you. For example, I have two vectors. Vector one, it is, let's say, in this direction. Vector two is in this direction, and vector three is, let's say, in this direction. So what would be the resultant in this case? Lulu, is it clear, beta? Are you getting the point or not?
So I'm getting the point.
So resultant will be like this. So you can say that this is the resultant, isn't it? But if I say that, yeah, this dotted is the resultant. But if I say that, okay, I have one vector in this direction, okay, one vector in this direction, okay, and one vector is in this direction. Actually, these are the vectors, coplanar vectors. So how to add them by their uh, resultant, or how to find the resultant of these all vectors. So you can select any one of the vector as a reference vector. Mostly, what do we select? We select x as a reference vector. So I will do not disturb the position of the x. Yani, this is the question. This is what? This is your question. And here I'm going to give you the solution. So you will not change the position of your x. Let's say this is what I will place this x as it is. I will place y at the head of this, and I will place z on the head of this. Now I will say that the resultant vector is from this point to this point. Is it clear to everyone?
सर ये वाला समझा दो
दोबारा समझा दें. For example, I told you that there are three vectors. They are called coplanar vectors or coplanar forces or coplanar vectors. There are three vectors. Let's say it is your vector f1, this is your vector f2, and this is your vector f3. So in these vectors, what do we do? This is a free body diagram. What is that? It is a free body diagram. So in this free body diagram, if I want to find the resultant of 3, what will I do? I will just keep this f1 as it is, right? Okay.
Yes, sir.
Then I shifted f2 from this position to the head of f1 this way. Then I shifted this f3 on the head of this. So this is basically, tip to tail method. Tip to tail mean tail and head. Then next will be having tail over here and head here. The next one will have tail over here and head over here. So what will be the resultant? Resultant will be basically starting from tail of first to the head of last vector. Remember, this is very important concept, really, really important, and your past paper questions have lot of past papers have lot of questions based on this idea.
So in case of the coplanar ones, we just need to flip the direction. I mean,
Yes, not direction actually, not direction. Basically, we have to figure out the uh, yeah, we have to apply head to tail method, right? Tip to tail method. Is it clear to everyone?
so could you
Yes, sir.
zoom out?
Yes.
Um, done.
Okay. So moving on. For example, if I have another question for you, that okay, I will just read this question for you because I have okay, wait. If I could make this possible, uh, where is my screenshot? Okay, I'm gonna send one picture in your WhatsApp, and hopefully that will be open up. Okay, where is our for group? Oh my, there's so many messages there at once. Yes, yes. Sometimes WhatsApp is not able to, you know, download all that stuff. Oh my God. This is just single one question and it is not letting me to get in. Hmm. Here is your growth. Okay. Okay. Sorry. WhatsApp is not responding. Anyhow, I will draw the diagram for you, and that these all will reach to you. These all I have sent some files on that WhatsApp, but it was not working. That is why I think I was not using my silly brain. Just a second. I had that file in my laptop, in my tab. So, sometimes, you know, I used to stuck that what I have to do. And yes, here is one of the question what I wanted to share with you. Physical importance. Yes, open with. Okay, now is this file visible to everyone?
Yes, sir.
Yes, sir.
Okay, sorry. There was question. Actually, these are the questions what I was solving for you. But unfortunately, my WhatsApp was not working. That is why I was not able to, send those files to you. Right? Okay. Here we go. Now check this one out. This was the question what I have solved for you. Now this was the question what I have solved for you. Okay, got it? This is the same question which would be solved by the same methods and so on. I will talk about these questions later on, Yani, but I am just leaving in between. Here is one of the questions. Yes, this was the question what I wanted to share with you. Is it visible to everyone? And are you people able to see that? A cyclist is traveling due south with a velocity of u. The wind is blowing from the northwest with the velocity uh, w. Right? This is u is the velocity of cyclist due south, and this is wind w. The wind has a velocity v relative to the velocity of the cyclist, where v is wind minus u. You got this? This is basically the final velocity of the cyclist. It is the difference of what v and minus v and u. It means v is equals to w plus negative of u, isn't it? Are you getting my point?
Yes.
This is
So
one
V
of
is
the
the resultant.
yeah. V is the resultant in this case because you are not having you are not having v. These are the two components. This is one of the way to figure it out. The second way is just shift this u on the other side and you get v and w together. But here it will be yani I will give you the idea. With vector diagram shows the magnitude and direction of the vector velocity v, right? So as I told you that for v your w should be in the same direction as it is. W is over here, so this is basically the w. And what about u? This was u, right? But what I have to do, then I will be connected this, or when I will place this u exactly at the head of this. This is basically this is what Okay, this is what? This is u plus w. So if I want to draw a vector, a resultant, that resultant will be from this point to this point. What will be this then? Yes.
But don't we change the direction of?
No, no, no. Wait. My question is not that. What will be this purple color vector? If this is your w, this is your u. So what will be this? Will it be w plus u? Is it?
Yes, sir.
Yes, na? Because they
Yes,
are
sir.
just directly connected or directly added. But now if I do the same thing in this way, that okay, I have w in this direction, yani I will change the colors accordingly. This is w and u is downward, but I have to add the negative u. So what to do? I have to draw a negative vector here. Now what will be the resultant? Yes, can anybody tell me? Isn't it like this?
Yes.
Yes.
Yes,
So
yes.
this vector is basically, this is your w, this is your negative u. So this is w minus u. So now let's see what is basically the direct diagram which is going that same type of idea. Yes. Any one of you?
Sir, A.
A. Who is this? Misha?
Yes, sir.
Okay. What
Sir
about the
B.
others? Mariam, Lulu, Saeed Abdullah, and Ali Faisal.
Sir B.
B. Okay. Hmm.
Sir, I think it's A.
Okay. Good. Next. Abdullah, what do you
Sir
think?
B.
B. Okay. Now, Mariam, what is your idea?
A.
Okay. So A is the right answer. Why? Let me tell you. This is basically this is basically your V. Is it? So V is pointing towards left side somehow. So this is right pointing right. This is pointing down left, this is pointing right up. So this is the only possible solution, but I can explain this to you with more detail. This is basically your uh, u sorry, w. Is it? Do you believe this thing? Is it is it na? And this was basically your, this was what, this was your negative of u. Now you will draw this negative of u exactly here on the head of this, right? Are you getting my point?
Mm.
Because you cannot draw the resultant from tails of two. You have to draw the resultant when they are connected by head to tail. Once they are connected by head to tail, now you will be able to draw the resultant, and that resultant will be basically drawn in this way. That is from this point to this point. Is this clear? It starts from tail of first to the head of last. Isn't it the tail of first and isn't it the head of last vector?
Yes,
Is it
sir.
Yes, sir.
is clear to everyone? So
Yes.
that is basically the situation what I wanted to tell you. And somehow some more questions are there. For example, we have learned about that how to resolve the vectors into components. Okay. Okay. I want to make one more discussion and then I will give you this worksheet. Just uh, solve this worksheet and move on. Yes. In case of equilibrium, in case of equilibrium, there is no resultant force, right? There is no resultant force. Okay, this is one of the things. So when there is no resultant force, there are two tricks which will be helping you to solve the vector questions, right? So the vector diagram will be a closed vector triangle. This is one of the identification. I will let you know. I will explain you. Just let me write the next point. Then I will explain these both of these points. One thing, that vector triangle will be, our vector diagram will be a closed vector triangle. Secondly, all the forces will intersect each other at a single point inside the body. All the forces will intersect each other at a single point inside the body, right? Inside the body. Yani, in these two cases mean that if you have a closed vector triangle, actually closed vector triangle means that if you have three coplanar forces, right? This, and this. So once you are going to draw their closed vector, closed vectors means they must be drawn in this way. Let's say this is blue. Okay, blue can be on that side, right? The red one will be on the head of this without changing the direction and magnitude. Okay, and this purple will be on the head of this without changing the direction of the magnitude. So don't you think that this is a closed vector triangle? This is a closed vector triangle. You have started right from here. This is your starting point. This is what? This is your starting point, right? And you reach to this point. Then you have connected the next vector to the tail of next vector to the head of this first one. And then what did you do? Then you have connected the tail of third vector to the head of second. And finally, what happened? That the tail of the last vector was basically, sorry, head of the last vector was connected to the tail of first one. Check this one out. This is the closed vector mechanism. Okay. So if you are able to draw this for any of the diagram, that object is in equilibrium. This is basically the coplanar forces. I will let you know. And the second thing what I was talking about, that if there is an object or a block, in that block there are several forces acting in different directions, right? For example, if the forces are acting in such a way that I'm going to draw their yani if I'm going to draw their lines, this is its line, this is its line, and this is its line. So they are not intersecting each other at a single point. So this is not in equilibrium. Okay. Other than that, yani for example, Misha, sorry, I'm just making hurry because I realize that you have a class ahead. So if I say that there are three forces, which one is in this direction, the second one is in this direction, and let's say third one is acting in this direction. Rather, you can say that these forces are in different positions. This is here. This force is anywhere here. So now you will draw their now you will join them. For example, if you join this force here, right, in this way, this is to be here, this is passing through this, again this is not in equilibrium. You got the point? So these are basically the techniques in which we deal that whether the object is in equilibrium or not. But if we say that, okay, in this object there are some forces, and these forces are acting in such a way that once you will join them all, they will intersect each other at a single point. So what will happen? That will be this object will be in equilibrium. So there would be a lot of questions from this uh, discussion, or you can handle the questions. Let me show you. For example, this was the question for which I told you. This is weight of the aeroplane, right? And this is the lift of the aeroplane, and this is basically there is another resulting force. This is over here, right? This is the resultant force. Then it is said which vector could represent the forces acting at the glider. So here there will be a word that it is in equilibrium, constant speed. Yeah, it is moving with constant speed, so it is in equilibrium. So if I say that the weight will always be downward, so just cross those in which weight has changed the direction. So in which weight has changed the direction, none of them. So it means all can be considered. Secondly, the lift must be in which direction? Towards right top, sorry, left top. So it means that here the lift has been direct, lift is direction of the lift is reversed. So this is incorrect. Simply straight, simply saying. Okay? Here the direction of lift is reversed, so this is gone. Okay? Okay. Wait. Where is, yes. Here, if you see in this one, the direction of the lift is in the same direction. Sorry, direction of R. I was talking about R. So the next force is your lift force. So lift force is in the same direction here in this, and weight is exactly downward. So that is why this is a closed vector triangle of, and that is why its option can be option D. Right? There can be some more questions. I have seen, yeah, this is one of the questions. Here there is an object, there is a force, there is an equilibrium condition again, and it is said that in which direct diagram the forces are in equilibrium. So can anybody tell me in which the body in which the diagram the object is in equilibrium? Last question, then I will not ask you any more questions. Hurry up. हमेशा आप बता के जा सकती हो. It would be A. Why? Because if you just draw the closed vector triangle of this, it will be here. Then draw the head of this here. Okay. Then this will be basically in the same direction. This is the closed vector triangle. Okay. So these type of questions, I will send you this worksheet, and I will request you all to please try the questions, and I will help you out to solve them all. I will compile. Actually, this is a complete worksheet of physics boundaries, but I will uh, compile this worksheet just for your vectors, and then I will send it to you. Okay? I mean, then I will discuss that in the next class. Okay, Ji?
Okay, sir.
Okay. See you then.
Okay, sir.
See you.
Allah Hafiz.
Allah Hafiz.
Thank you, sir.
Allah Hafiz. Allah Hafiz.
सर
जी बेटा.
सर आपने बोला था वो एडएक्सेल का वो वर्कशीट भेज देंगे तो मुझे भेज दीजिएगा, मैं वो वीकेंड पे दिन सॉल्व कर दूंगा.
बिल्कुल ठीक हो गया, मैं भेजता हूँ.
सर कौन से टॉपिक का
ठीक है,
भेज देंगे?
मैं सारी भेज देता हूँ एक साथ में.
ओके, थैंक यू सर.
ठीक है, वेलकम.
अल्लाह हाफिज सर.
अल्लाह हाफिज. अल्लाह हाफिज.